Hello, Professor. So basically, our project, which is based on self-healing of the IoT nodes in a network, uh, uh, we have basically two components: the hardware and the software component in this project. Uh, so I'll be explaining the software and what we are going to do and how we are, which algorithm, the algorithm and the method we are going to use for the self-healing of these nodes. So basically, whenever there is a node connection issue, we get the information from the neighboring node. So in each node, whenever a particular node uh, um, uh, connection is detected, the software receives the signal from the hardware through an interrupt, where based on this interrupt, in the interrupt service routine, we'll be enabling a reroute flag. So in our software, basically, we'll be polling for this reroute flag, and whenever this particular flag is set, we'll be running the rerouting algorithm of the entire network. So to go into this particular thing in detail, basically we are detecting a particular issue through an hardware filter, which detects the malware or any corrupted packet, or it receives the continued information from a neighboring node. So this particular data is passed by the hardware filter, where it's communicated through a special packet. So whenever this particular special packet is passed, is received, the hardware detects this particular special packet, and then it passes the special packet and identifies the node IP address of the node which is corrupted. So along with that identification, it also generates an interrupt and tells the software to process this particular thing. So whenever this particular packet is detected, software reads this particular packet in the register, and gets to know about the IP address of the information through a register, IP address of the corrupted node through a register, and then it starts its rerouting algorithm. And once this rerouting algorithm is done, it will update the routing table based on the information detected. So all this is taken care in the software side, and then all this detection and the communication of this packet, or communication of this IP address with all these, and passing of these special packets is taken care by the hardware, which Manoj and Biao is going to explain.
Okay, so our hardware basically contains two cores and a Bloom filter. So core one looks for irregular behavior from a node. To define one such irregular behavior is invalid destination address. For example, let's say node 0, the node in node 0 is never supposed to communicate with node 4 because of some constraint. But for some reason, node 0 is corrupted and it is trying to get to node 4. So that means it will be it is an invalid path. So core one basically has a memory that has all the valid source and destination path there. And as soon as the data comes in, it looks at the header to find what the source and destination and see if the path is valid. So an illegal access comes in and then it just drops the illegal access packet and then creates a corrupted node information and sends it to go through and then sends it out. Similarly, when when the access is legal, but the data itself is corrupted, we use the Bloom filter for that. So we have a corrupted data coming into the Bloom filter, and then the Bloom filter calculates it. And if it is corrupted, then it's gonna give out the source address of that packet to Core2, and Core2 is gonna package it up in a UDP format and send it out. And if the data is neither corrupted nor illegal, then nothing happens and it just passes through our pipeline as depicted here. So currently I'm working on designing the Bloom filter for the design, while Bia is working on the ASM code for the core 1 and core 2 to for core 1's behavioral check and core 2's drop and packet forwarding mechanism. Thanks. Bia will further explain our progress.
Yeah, as of now, the self-healing algorithm for each node is there, but we still need to find a way to bridge the results coming out of that algorithm to how the deter lab nodes are going to use that information to adjust their rerouting. And Sachin is working on some options to realize that. And we're also exploring some other options to see which one works better with the deter lab environment.
Thank you.